So what we're going to look at for the rest of today, for the rest of the next hour and a half, is a very high-level overview of C++. We're going to look at what C++ is, and then we're going to spend quite a bit of time quickly revising data types and how they differ from C, briefly declarations and definitions, pointers, and we'll introduce some new stuff to do with const and references and stuff as we go. Okay? If you've got questions, basically yell them out as we go. This stuff, most of it you should know. Some of it you might not, okay? Some of it might be a bit confusing, okay? So it's going to be quite fast today. I've got about 100 slides to get through, okay? So take a look at them afterwards as well. I also have some live code, hopefully, to fire up. Okay? So what is C++? It's built on C. It basically was originally called C with classes, okay? And it's got a high degree of compatibility with C. So you can write C code and compile it with a C++ compiler, and it should compile. Not always, but it mostly does. Okay? It's also influenced a lot of new languages, so Java, C#, D, Go. There's lots of languages it's influenced. Okay? So that's one of the reasons why we study it, is because it's got a lot of stuff in there. It's a very big language, and it's influenced a lot of more modern, up-to-date languages. Okay? So what is C++11? So C++11 is, well, according to the slide, the most recent iteration, okay? Now note, actually C++14 has come out, okay? But C++11 is the most up-to-date complete standard, okay? And it introduced a whole lot of new functionality into C++ that we're going to look at, okay? Mainly around references, which we'll get to, and things like move semantics and smart pointers, okay? So this is all to do with memory management. Lots of stuff to do with memory management. In terms of compiler support, this is why we're using C++11. GCC, which is the compiler we use in the school systems, is up to date with C++11. C++14 has come out, okay, but it's very unsupported even amongst GCC, okay? So if you see C++14 code, be aware it might not compile, so double check it does, okay? But C++11 is the big standard that we're using, okay? And the textbook is all up to date on C++11 as well. Okay, so the reason why we're not strictly teaching object-oriented programming is you'll hear people say, oh, C++ is an object-oriented language. It is, but it's not just that. It actually supports lots of different programming paradigms. Okay, so it supports procedural-based programming. That's just whereabouts you start at the top and just go next, 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 next. It supports object-based programming, which you would have done in C. We've actually got things like structs and representing for data as abstract data types. You've then got object-oriented programming, which is basically classes, what you would have done in Java before. So you don't just have the structs, you've got the whole idea of inheritance, you've got the idea of public and private data, and lots of things you can do with that. And then we've got generic programming, which is using templates, which we are going to spend a lot of time looking at. Okay? Generic programming is probably what most of you haven't done before. Okay, so that's how do we write code? Okay, so how do you write code that, say, summed two numbers, so added two numbers together, okay, but didn't just have to work on ints, and didn't have to just work on floats, didn't have to just work on doubles. You could work that sum function for any data type you gave it, okay? That's what generic programming is. How do we write some code that allows you to sum two numbers, given any two numbers, how would it work, and how do we write the template to do that? Okay, so the key features of C++, okay, there's a lot of them. There's the basic types, operators, expressions, and statements, which we'll look at today. There's pointers, references, and arrays, which is a little bit of today and a little bit of Thursday. There's the idea of namespaces and separate compilation, okay? That means that I can get somebody to write one library, and I can write my own code and interface through it through an API, and that all works. And so I can distribute objects. So I don't have to distribute source code. I can distribute compiled binaries. I can compile my code, link my code against those compiled binaries already. There's complex exception handling. So again, we're going to look at that later on, about week 5, I think, alongside the memory management. So when we have an exception, so if you're coming from the language of Java, when you got a problem, you throw an exception, you catch an exception. Same thing as C++, that's what we're going to look at. We're looking at how does the memory work for that? How does, when things get destroyed and we have exceptions thrown out of them, what happens? Then we're looking at for data abstraction. So data abstraction, user-defined types, polymorphic types is object-oriented programming type stuff. Then classes and objects, again, object-oriented programming. Templates, which I've mentioned about 6 times already, and the standard library. The reason why I keep on mentioning the standard library is similar to the Java API, you shouldn't need to go write your own linked list in this course. Okay? Unless I give it to you as an assignment, you should not need to go write your own linked list. You just use the one that C++ already provides. Okay, so we keep on talking about that. There's more slides about that. So there's lots of libraries, okay, not just the standard template library. There's lots of libraries available for C++, again, that we'll cover. Okay, so if you ever think I need to go code something from scratch or how I do something, often there's a standard library available for doing so. Okay, and again, the textbook and lots of the links that we refer to will cover this. Okay, also for tutorials we'll cover a lot of this stuff. So the library, standard template library, contains 3 different components of it, key components. It contains a list of containers or set of containers. Okay, so that means a vector, a list, a stack, a queue, all those sort of things. It also contains a set of algorithms. The algorithms do not just apply to a particular container. Okay, so something like sort, you might not have your vector and go vector.sort. You might not have your map of something and go map.sort. You instead pass the container into these algorithms and they're generic. They are designed to handle these things. Okay, so if you're coming from Java, this is a slightly different way of doing stuff. It's for ordering changed. We also have iterators, and it's the same thing again. Iterators are independent of their containers. There might be particular iterators that only work on some containers, okay? But for iterators are not necessarily strictly container dependent, okay? Now everything in the standard template library, by its name, is a template, and also the standard template library is not object-oriented, okay? So we're not going to really talk about inheritance and virtual functions at this point, okay? But just be aware that not everything, or most things that are in the standard template library are not not classes, not object-oriented. Okay, which allows us to do this multi-paradigm programming. Okay. So enough learning what C++ is. Let's look at some code. So one thing I should quickly state: alongside for lecture slides, for code for each week of these slides, there should be a sample code that you can download here, and it should be a zip file of all the code that I am covering here. Okay, so this is Hello World, C++ 11 style. Okay, and so this looks very similar to a C style Hello World. It's hash including something. In this case, it's hash including a thing called IOStream. Okay, so instead of hash including standard io.h, you're hash including IOStream. You've got a main function. Okay, that looks like C. But then you have this interesting thing here. It says standard cout, hello world, less than standard endl. Okay, so no printf. Okay, printf is C. Okay, we're going to be passing all these things through what's called streams. Okay, so IOStream stands for input-output stream. Okay, cout is for console output stream. This less than sign is called input redirection. It means that everything gets redirected out to that stream. Okay, and then of course we have our return statement. Okay, so in this 9 lines or so, you have a lot of stuff at this point. You have a comment, you have include. Okay, you should already know what include means. You've got parts of the standard library. Okay, so that standard : is invoking the standard library. You're using the output stream. You're using the stream insertion operator, which is less than. Okay, it's also output redirection. You're also using for endl. Okay, so again in C you would have used \n for the end of the line. Okay, I shouldn't need to see any \ns at all in this course. Everything should be using endl. The reason for that, if you move from a Linux machine to a Mac, or from a Mac to a Windows computer, \n means different things in different computers. Sometimes it's \r, sometimes it's \n. Okay, for standard NDAL will allow for compiler to sort it out for you automatically. The standard everywhere for STD is called a namespace, so it's allowing us access into this particular library's namespace. Okay, we'll talk more about that on Thursday. We've got a return statement, and we've got, of course, the standard semicolons, braces, and string literals. Okay. So jumping back up to that slide there, other bits and pieces to stress. You're welcome to code in whatever IDE you want. Okay. In 2911, if you do that course, we tell you have to use Eclipse. Okay. I don't care what you use. You can use Vim, you can use Nano, you can use Emacs, you can go use Eclipse if you want to. I'm using a thing up here called Geany. You can use whatever you like, provided that you're comfortable in it. Okay. But one side note about that is we will not provide technical support for it. So code where you feel comfortable, but just be aware we're not going to provide technical support for your IDEs. And again, I stress, make sure your code compiles off the command line on the CSE system. So how do we compile this? Okay, we bring back up our compiling flags. Okay, and here's our command up on the right-hand side. Okay, so we say G++, okay, so you might have used GCC if you're compiling in C, for compiling C++ is G++. The standard is C++11, again, turn on all warnings, turn on all errors. For O2 is the optimizer, okay, it just makes our code run a little bit faster. We're outputting to a file called hello world, and the file we want to compile is called helloworld.cpp, okay? So this is going to compile that helloworld.cpp into a file called hello world, okay, and it runs. Then to run it, we /hello world, and it says hello world, okay. Hopefully people are excited by that. Okay, so what happened there? Like that one command actually did three things. Okay, the pre-processing happened. Okay, so what pre-processing does is like for hash includes. When you say hash include, what it does is it goes off and gets a file, gets the entire contents of that file, so the IOStream file in this case, and it puts it into your document. Copies the entire file into your document. Okay, so we hash include all this IOStream stuff, all this tons of code. Then we compile it. Okay, so we compile it from the .cpp file to machine code, and what that will do is it creates an object. Okay. Now the command I've given here actually is not creating the object; it's going straight from object to the application. Okay, but I can give this a slightly different command. I can give this this command here. Okay. I can give it this command here, which is the same. Start of that's the same. Okay, but the end of it's different. The end of it says instead of -o hello world, it says -c hello world.cpp. Okay. What this then creates is not the hello world application. It creates a thing called a .o file. Okay. So it goes out there. And now I have a thing called hello world, okay, which I created before. I've my source file called hello world.cpp, and now I've got this new file called hello world.o. Okay, this is a compiled object. Okay. Then what we do is if we have multiple .o files, okay, this will happen later on, of course, when you have big complex programs that are invoking different applications, different APIs and things like that. You then have to link these .o files together. Okay? Now, I don't have a simple example in front of me, unfortunately, to do the linking too much. So the code to do the linking is simply that. G++ again, we're taking in hello world.o, we're outputting hello world. Now, this is going to convert my hello world.o file now actually into a final application. This is going to do the linking. Okay? I do that, and hello world says hello world again. Just to prove I'm not faking it, I'll remove hello world. Okay. So there you go, hello world disappeared. I'll actually even remove the hello world.o file. Okay. Okay, so we're back to the source code only. I'll do it for compiling stage. Choose that one, so we're going to compile. Okay. So now I've got the .o file, and then we'll do the linking stage. That one. And now, when we do hello world, it says hello world again. Okay. So for the first assignment, for the first little bit of what you're doing, you won't need to separate out your compiling and your linking. Okay. But in later parts of the course, you will. In assignment 2, if I get it to work correctly, assignment 2, what you're going to do is you're going to provide me some source code. I'm going to compile your source code to a .o file. I am going to provide my own .o file as a test file, and I'm going to link them together. And then I'm going to run them. And that's probably how assignment 2 is going to work. I'm still working on the little bits and pieces of exactly what will require you to do and what I will require myself to do. Okay, but they'll be different. First assignment, you're reading in a text file. You're reading a text file and printing some stuff out. Second assignment and later assignments, you're providing some source code. I'm providing some source code that talks to your source code and making it work together. Okay, and there'll be instructions for how we get this all to work. Okay, but this is how a lot of programs work. You get these things called objects or APIs. You get given a tool set. These are some codes and libraries that you can use. Now you write your own code that interacts with them. Okay, so that's exactly what we'll be doing in the second and third assignments. Okay, so if I haven't overwhelmed you by this stage, the point that we want to make is C++ is complex. Okay, so there's full backwards compatibility, or almost full backwards compatibility with C. Okay, but that might bring some baggage with it. Okay. It means you've got problems with pointers and casting, okay, that C++ 11 tries to wipe out, okay, but you have full backwards compatibility with C. So if it would actually help you on the first couple of weeks, maybe you do write in C and then gradually replace your C-style stuff with C++ 11 style stuff. Okay, there's an emphasis on performance, okay? So C++ allows you to do deep, dark stuff. There's a bit of black magic sometimes. Deep, dark stuff with memory, okay? When you're compiling on a particular architecture, on a particular machine. So my .o file here that's compiled under Linux, I can't move that to Windows and just have it run. I have to recompile it because C++ deeply compiles to the architecture of the machine that you're working on, okay? Now, if you're coming from Java, that's different. With Java, if I compile a .class file on my Linux machine here, I move it across to Windows, provided that the same Java JVM is installed, it will just work, okay? So there's quite a bit of difference in the compilation process. You can also make your user-defined types, so your classes, your structs, behave as if they were similar to built-in ones, okay? What that means is we can do our own rules for how the plus operator works, how the minus operator works, how the double equals operator works, okay? We'll cover that in about week 3. It means that we can do very powerful things with the language. We can build our own extensions into the language. We can also build our own extensions into how casting works for classes and stuff that we define. Okay? But there are some problems with this too in particular. One, when you get an error message in the compiler, I can tell you it's not very helpful. The error messages in the compiler are often very cryptic, and you'll do one mistake, you'll leave a semicolon off somewhere, and you'll get a wall of text. Okay? Unfortunately, you've got to learn to live with that. Sometimes Googling will get you Stack Overflow pages that will help you out, okay? But be aware of cryptic error messages. My recommendation is compile often. Don't be scared of compiler. Write 5 lines of code, compile it. Make sure it works. It also trusts, C++ trusts the programmer, that's you, not to violate the language rules. What that means is if you're overloading the plus operator, okay, to say do my function that said add 2 numbers together, okay? Adding 2 numbers together should add 2 numbers together. If add 2 numbers together multiplies 2 numbers together, okay, you can do that all you like, but it doesn't mean it's right, okay? So it's up to you to not do stupid things, okay? It's up to you to obey conventions and things like that. So when we're talking about conventions, style. Common idea, place declarations in the .h file. I'll explain what declarations are in a minute. Definitions go in .cpp files. And in terms of the style guides, with the exception of what I mentioned about 10 minutes ago, you don't need to worry about, oh, am I allowed to use this? Am I not allowed to use something else? Okay? Style is completely up to you. Having said that, there's 3 suggested style guides there. My recommendation is the Google one. It's actually the most in-depth. I was going to bring it up on this screen here. But if you go take a look at the Google one, there's a whole lot of stuff, again, lots of text, but how things should work, why you should use header guards, for argument's sake, how you should declare stuff, when you should use things like inline functions. Don't worry about reading all this now, but if you have questions about how things work, go take a look at these guides and Google them or search them and figure out what should I be doing, sort of thing. When it comes to marking assignments and stuff, what we'll be looking for is consistency. So if you've done something in a particular style, make sure you've done that style the entire way through. Okay? And that comes down to variable naming, function naming, where you put brace, so where you put braces, and all that sort of stuff. So for argument's sake, I don't care if you put the brace to start main layer or you put the brace to start main layer. I don't care. But whatever you do, just be consistent all the way through your code. Okay? That's what we're looking for. Okay, so this is a repeat of the slide that we had earlier to do with if you are coming from the land of C, the stuff that you should be trying instead. Okay, so just take a look at that slide later on in your own time. Okay, and again with OO, the stuff that you should have an understanding of already is that you have objects. Objects are constructed from constructors and from types. Okay, so what does that mean? You've got some built-in types, so you've got your ints and your floats. You then have all your user-defined types. So string and vector, which are in the C++ library, are a user-defined type. Your types that you make by declaring them as classes are also constructed into objects. We then have type conversions and polymorphic types. Type conversions are casting. That happens at compile time. Polymorphic types is what happens at runtime, again with inheritance. If you're coming from the land of object-oriented programming, you'll know that if I have a book, and I have another book called a non-fiction book, and it extends or inherits from book, that type is polymorphic, okay? So we'll talk about polymorphism right down in about week 11, week 12, okay? But just be aware you can do that. And then with these objects, and once we compile these objects using the constructors, we then can perform computations on them by calling them member functions, okay? And that means that we can use them as variables, statements, expressions, okay? This is just buzzwords, programming buzzwords. You should know what 90% of the stuff means already, okay? But in order to understand all this, well, you need to have a solid understanding of the basics of C++. So the next 10 slides or so is going to probably be quite boring, but we're going to take a look at each of the basic types. And they are, of core C++, including types, are your type system, your declarations, your definition, scopes, namespaces, strings, arrays, input, output. Okay, that's going to be for the rest of this week.